mine. It's a framework.
Is that what that is?
Yeah.
Oh, wow.
Mm-hmm.
What modules did you get? Did you like buy any Wi-Fi or like LAN modules or anything with it so you have a LAN?
I've got Ethernet, micro SD, 2 USB-A, 2 USB-C, and HDMI.
Did you do the motherboard upgrade when they come?
Nope. This is still the original.
I've seen where people are doing the motherboard upgrade, they're taking the old motherboard and just like patching it like a home server.
Mm-hmm.
You know, just have the motherboard.
I have the blinking light. That means we're going to start soon. Yeah. We'll see what it ends up being. All right, I've got the green light. Good morning, everyone. How has South been so far? It's awesome. So today we're going to talk about LXD, which is System Container Technology. We'll get to that in a second, though. So some professional info about me. I am a small business owner. I write websites and applications for people and run whatever they like, open source preferred, of course. I also host a few podcasts, Linux Lads and Linux Downtime. Linux Downtime is in the late night Linux family. That's pretty cool. And I'm also working on Redacted Life with a friend of mine. I'm also a musician. And my website is down there. All of my contact information can be found on secluded.site. And with that out of the way, let's get to it. So throughout the presentation, I'll be using a URL shortener and they'll look like that. So when you see 4 alphanumeric characters in parentheses, it's url.run/ those 4 characters. And you can find more information about whatever I'm talking about. I wrote the URL shortener. It has no IP logging, no click counting, and it is currently running in LXD. And that'll be what I demonstrate towards the end. And there's the source code. Don't judge me, it's not great. It works. So why do we care about virtual machines and containers? Isolation. Before I get to that, though, how familiar is everyone with virtual machines by show of hands? Okay, cool. What about containers? What about system containers? Neither Docker nor Podman. Cool. That's what this talk is for. So everyone raised their hands at some point, so I'll kind of breeze through this bit. So isolation, flexibility, and portability are some of the big 3. You want to isolate processes from each other, so your web server cannot, for example, your web server cannot be given direct access to like your email server, for example. So an attacker cannot penetrate your web server and then pivot laterally and move to your email server, for example. They're also extremely flexible. With virtual machines and containers, you can set a particular amount of RAM or CPU or disk or any of that. Whereas with a bare metal machine, you get what you buy. And then they're portable, so you can like pick up your virtual machine or pick up your container. They're boxes, basically, black boxes. They do what you meant them to do, and that's it. You can pick up that box, pop it between servers, it doesn't matter. And you can also cram bare metal machines full of virtual machines or containers. And it's cleaner. If you install an application on the bare metal host and then want to remove it, it might take a little bit to pick up all the scattered pieces throughout the system, throughout the file system. But with virtual machines and containers, you can just delete the virtual machine or delete the container, and it's gone. So we'll talk a little bit about how virtual machines work. You have multiple operating systems or guests on one physical machine, and hypervisors provide virtualized hardware for the guest operating systems. That'll be a virtual display, virtual CPUs, disks, that kind of thing. Type 1 hypervisors run directly on the host hardware without an intermediary operating system. So that would be your kernel virtual machine, which is what KVM stands for. And we'll have a diagram in a second. Type 2 hypervisors run in user space, and a good example of that is VirtualBox. You can install VirtualBox on Ubuntu or whatever you like and run your virtual machines, but it won't be as performant as the type 1 hypervisor KVM, which is running in the kernel. And there is a little diagram. We've got I originally had these swapped, so I erased and then renamed them so the diagrams are correct. Our type 1 hypervisor is over here. We've got a guest operating system kernel, hypervisor host kernel, and so on. The type 1 hypervisor does not have the host operating system in the middle. So your applications running like up in this layer have fewer layers to travel through to get to the hardware, and they end up being a lot more performant. You can get near native performance with KVM, but with something like VirtualBox, it'll be much slower. And then let's talk a little bit about containers. So containers are exclusive to Linux. Containers in the way DevOps people know them usually are exclusive to Linux because they use features baked into the Linux kernel like namespaces and C groups to achieve that isolation. Docker containers on Windows and Mac OS run in a Linux VM. That's what the Docker engine provides in the background. So namespaces partition your kernel resources, and that'll be your process IDs, host names, directory hierarchies, that kind of thing. And then C groups limit, track, and isolate your hardware resources. And that C groups is short for control groups, and that allows them to do things like mitigate fork bombs from affecting your entire system and spreading and crippling the host system or other containers. The fork bomb will still execute, and it will still cripple that container, but it won't spread beyond that. Huh. Oh no. My laptop locked. Cool. What? Yes. So then we've got a diagram. So in the container world, there are even fewer layers for your applications to communicate through. You've got your applications on top, guest operating system, and then your host kernel, and that's it. And the guest operating system could be like Alpine Linux is very popular in Docker. Maybe your guest operating system is just an init system, and that's it. I've seen a lot of Docker containers like that. But with system containers, like what LXD provides, you'll have like Ubuntu, an entire instance of Ubuntu running in that container, or Debian, or whatever you like. So now I'll talk a bit about when to use virtual machines, when I think it's appropriate to use virtual machines. So virtualizing esoteric hardware. You're, for example, writing a kernel, and you want to make sure it works with these weird pieces of hardware that your users say, hey, I want to run this, it doesn't work, I've got these issues. You can virtualize that hardware, debug things, and make sure the drivers work correctly. You can also virtualize foreign operating systems. So with containers, you can only run Linux systems in Linux containers. But with virtual machines, you can virtualize anything. Run Windows, Mac OS, Plan 9, whatever on Linux. Or any of those systems on Windows. And they're also useful when you want to completely isolate processes from each other using a decades-old technique. Virtualization is old, it's battle-tested. Some like regulatory bodies say you have to use virtual machines and you cannot use containers. And Drew DeVault has a very good blog post called In Praise of QEMU, and he describes how he uses QEMU to great effect. And we can actually maybe look at that a little bit. Cool. So that's what it kind of looks like. It's short, sweet, not a long read. And then we will get back to this. Now, when would you use application containers? Microservices, of course, that's where they dominate. Extremely reproducible builds are very popular for use with containers, but I think Nix is probably a better fit for reproducible builds. Or when you're dead set on using cloud platforms with extreme scaling capabilities, like Google Cloud Platform or AWS or Azure and so on. With those, you can write your application to run in a container and scale it down so there are 0 instances of it running and it doesn't cost anything. And then when a user hits that endpoint, that service, whatever, it spins up a container and then serves that user and then spins back down to 0 cost, which is pretty nice. Pay as you go is what it's commonly called. Or when the app you want to run is only distributed as Docker and the developer refuses to support anything else. This is a pet peeve of mine. I hate this. I think the administrator knows their environment better than the developer, and the developer should not try to shoehorn the administrator into using Docker when the administrator does not necessarily think it's appropriate, in my opinion. But luckily for us, Docker does run in LXD. And for system containers, everything else, I like system containers a lot. So now we've got a crash course, really quick crash course to LXD. You can run LXD as a native application on Alpine and Arch. It is in the official repositories, but it's a huge headache. Snap is easier, as much as I dislike Snap. Snap install it, initialize it, and then we can launch images. So this is a built-in image server maintained by Canonical, and it stores things like Debian systems, Alpine, Alma Linux, Rocky Linux, tons of different things. And then you specify the version you want to launch, and then whatever name you want to give the container. And then we can shell into it. And then from there, treat it like a virtual machine. Install your stuff, set up your automation, your backups, all that kind of stuff. And then we're going to execute a fork bomb. That's part of the demonstration. So, like as I said before, C groups, control groups, are in charge of your processes. So limits.processes is a configuration line, and that can be set per container or for different profiles, and those profiles can be applied to the various containers. And that defines the number of child processes a container is allowed to spawn. So once it reaches that threshold, if you execute a fork bomb in a container, it will fork and spawn child processes until you reach that threshold. And once you reach that threshold, the kernel's like, no, you cannot have any more processes. You're done. And at that point, treat it like a VM, destroy it, recreate it, restore from a backup, any of those methods we're used to using with virtual machines. And that's how you set it for profiles. There's a default profile in LXD, helpfully called default, that we can use for that. And then we're going to run an application, which is my URL shortener. So let me know if you guys, does that need to be bigger? Tell me when to, okay, cool. So we're going to SSH into a server, apt install snapd. This is a Debian 11 system. And we are going to do it from the beginning. Installing snap installing LXD. I said installing and I typed install. There we go. And this will take a minute. Yeah, it usually takes a while because snaps are rather large, unfortunately. So what we're going to do is look at the application. I put a space in there. There we go. We've got binaries here. This is a Go application, so installing and running it is as simple as downloading and executing the binary. There we go. Now, is this going to work, or do I have to add it to my path? Actually, I don't even have Vim installed. I don't think. No, I do. Okay. Yes, this is an early morning. It's been a while since I did this. There we go. Okay, now we should be able to use LXD. So we're going to initialize it, and you can genuinely accept all of the defaults. They're really helpful. So LXD clustering is an awesome feature. You can set up clusters of LXD instances and say, I want 12 of this container, and it'll just spawn all of those on the system. And we're going to create a new storage pool, call it default, and it's going to use B-tree-FS, but you can also use Ceph, regular directories, or LVM, but B-tree-FS allows for some awesome snapshot capabilities. Make a new pool. We're not going to use an existing empty device. We're just going to make it on the VPS's file system. 7 gigs is fine for our purposes. MOS is an interesting thing by Canonical. It's called Metal as a Service, and it allows you to point MOS at a full data center of hardware, and when you want to provision a new bare metal server, you can tell MOS, I want something with this much CPU, this much RAM, this much disk, and it'll go out into your data center and find a machine that matches those specifications automatically, then provision it with whatever operating system you like, and automatically set up LXD and containers. I'd never heard of it until the Ubuntu Summit last year, but it sounds awesome. We're making a new network bridge. We're going to call it LXD BR0. We're going to use automatic IPv4 and IPv6 addressing, and I'll show you what those look like in a second. And making the LXD server available over the network has some cool implications. While it is going through that, so HEL1 is a server I have in Helsinki. It might not work. Looks like it's not going to. How about this one? There we go. This resolution is tiny. I'm sorry. I just want to give you a view of the table. So this is a remote system where I have all of these different containers actively running right now. And we've got IPv4 addresses here, IPv6 addresses in this column, and we can do things like stop remote instances from a local machine, start them, launch them, restart them, shell into them without having to fiddle with SSH keys or anything like that. It uses certificates and passwords for authentication. Okay, and then the other option we skipped through is updating stale cached images. So once you launch something like Debian 11, it's going to download that image, unpack it, set it up on your file system, but then cache that image you downloaded so the next time you want to start one, it's instant, almost instant, really, really fast. But then you've got that image downloaded, and the LXD daemon will in the background check whether there's an update and periodically download that new one to make sure you have a fresh local copy. You can disable that if you don't want automatic updates. So we're going to stop test2, and then delete it. You can delete -- force, but it's better practice to explicitly stop it and then delete it. So you don't get in the habit of typing force and then accidentally delete something you didn't mean to delete. So let's get into test. And then let's see here. I'm going to do this in tmux. So if I accidentally get disconnected, processes running on the server don't hang and break and then corrupt everything. So I'm going to push a file I have here called fork into the test container in the root directory. Remote, As specified a remote, that colon syntax here says use the remote called test. But in this case, I don't have any remotes configured. The way you refer to a directory inside a container is that container / the directory. There we go. And now we should have fork.sh. And before we do that, I almost messed myself up. Let's see, what was this? That's what I want. Thank you. And then I enable caps lock. Let's say 5,000. That's probably a good number. I haven't done like a ton of testing in process limits. You should probably do that before you start setting your limit to 100 or something. I typed it twice again. Now we're going to execute that fork bomb. And suddenly we see a resource temporarily unavailable. It's used all of those 5,000 processes. We can disconnect, show that the host system is still responsive, and do images Ubuntu, I don't know, 2004. Call it test 2. We can create a new container. I'm going to shell into it once it's finished. Ubuntu is pretty large compared to Debian. Test 2. We can list stuff. We can apt install Nginx. It's going to work. Everything's going to continue running, even though in that other container there's a fork bomb actively, well, it was actively spawning child processes until the kernel said no. So we're going to delete, if I can type, force, test 2, because I don't care, and then LXC list our containers, and it prints out a nice table if your resolution is higher than like 720p or something. I don't remember exactly what this is. But when we try to shell into it again, we can't, because the kernel won't allow any more processes in that container to spawn. So we have to delete it, and then recreate it. Well, I call that one test 2, but we can rename test 2 to test. We have to stop it first, and then rename it. And there it is. It's got that IPv4 address, and it does not have an IPv6 address. I'm not entirely sure why that always happens, but this is all inside of one host machine, so I don't think it's a huge issue. If you are using clustering or having thousands of containers on one machine, then it would be a bug to fix. Sometimes it comes up after a second, just like it did there. Cool. So there's the IPv6 address and the IPv4 address. So we are going to delete it again, launch it, but instead call it URL. Get in tmux again, shell into URL, wget, install wget. Grab that binary I mentioned. Make it executable. Execute it. It creates a config file. Edit the config file. We'll call this self 2023 super secure. And also bind it to all interfaces. I forgot that when I was testing yesterday. So now we execute it. It is actively running, bound to 0.0.0.0 port 1313. So we're going to detach from that session, edit our web server config file, tell it to reverse proxy but I have to grab the IPv4 address, or IPv6, but I'm just going to do IPv4 for this reverse proxying. port 1313, comment this stuff out, restart Caddy, and if everything goes as intended, here is our URL shortener running inside of a LXD container reverse proxied from the host with Caddy. So then we can log in, and we said self 2023, and hey, look, we have this. Let's shorten this one. There's here, our short link is that, so we can do demo domain slash that random 4 characters, and we've gotten through. And that is running an actual application in LXD. Granted, it's a simple application, but that's what that process looks like. And now we have ample time for questions. Yes. Does anyone have any questions? Or does anyone want to run the mic? Is there a mic up there? I don't know. I'll just repeat questions.
Okay. I noticed you were running as root. Is that a requirement?
No. Do you mean running as, the question was, he noticed me running as root, is that a requirement? Do you mean inside the container or on the host?
On the host.
You can give, LXD runs as an unprivileged user by default, so they are unprivileged containers not running as root, but by default, only a root user can interact with those containers. But you can give other users, you can add other users to the, I think it's the LXD group, and they'll have permission to interact with those containers, launch new ones, shell into them, and so on.
Okay, so I don't have to worry if you escape the container that you're now.
No, that's part of why I like LXD. And there is, I think there's a page in the Arch Wiki about that. Yeah, unprivileged containers. And this is part of why setting it up as a native installation on Arch Linux and Alpine is a bit of a pain. You have to set up that unprivileged access manually. With the snap, that's how it works by default. And it takes care of that for you. Any other questions?
Can LXD show you the status of the containers that are currently running?
Yes.
And show you if they are maxing out their CPU or processors?
I don't know about see if they're maxing out their CPU, but you can see whether they're running or not.
Okay.
I don't think there's a way to see resource use per container using the default client. LXD does have an HTTP API, a REST API specifically. Let's see. Yeah. And there are some like web-based clients do exist, and I think, let's see. I've seen a web client at some point. Maybe not. I think this one would have been it. Beautiful, thank you. No. Are there any screenshots? Yes. You can kind of see that a little bit. So you can see what instances you have running, what profiles you have set up, all of your different networks. You can have multiple networks. I just used the default one. Projects, what kind of different storage pools you have for containers. I don't see anything about performance, so maybe not. But you could, of course, build that into a client if you wanted to. Any other questions? There are two right there, so we'll see who the mic goes to first.
You referred to this as a system container as opposed to Docker being
Application containers.
application container. What's the difference? I mean, what makes this a system container?
So it's a system container because it is designed from the ground up to contain an entire system. So like all of Ubuntu running at one time, or all of Debian. Whereas application containers are usually as little as possible, stripped down as much as possible. So it's your application and then maybe one or two dependencies or libraries. Yeah. Does that answer your question? Cool.
So you briefly mentioned multiple networks. So can you attach different containers to different bridges?
Yes. You can do that with the profile and say, this profile uses this container bridge, or this network bridge, that kind of stuff. You can also do some, it requires several, I'm told it requires several layers of networking wizardry. I am not a networking wizard. I'm very much a novice. But I'm told you can do things like bind public IP addresses to particular containers even. So if you run something that is not HTTP, that is instead like UDP or TCP, then you can pass that connection directly through the host and through LXD. Any other questions? Oh, okay.
So just to follow up on the previous question here, you mentioned earlier, I believe, that VMs and LXD are, similar in some ways, but ultimately it sounded like the big advantages with LXD is that ultimately you can have them spin down to basically nothing when they're not in use compared to a VM.
Yes. In that situation, they would only take up the disk space required for everything you have installed in that container and that operating system and that kind of stuff. Yeah. And the other big advantage is that they're really, really lightweight. With a virtual machine, you're virtualizing all of that hardware, but with a container, it's just using the host. It's sort of running directly on the host system. It uses kernel technologies to isolate itself, whereas with a VM, you're virtualizing all of that stuff. So there's less stuff going on.
So I think I'm still missing a nuance here.
Okay.
You've got these application containers and then you've got system containers. And you seem really enthusiastic about system containers. But is there a difference beyond just system containers run more stuff?
For me, the difference is workflow. I prefer interacting with virtual machines, and LXD gives you that way of interacting with a system, but with containers instead. Does that make sense? Okay, cool. Whereas with application containers, you've got your Docker files or your whatever Podman uses. I don't remember. Yeah. I just prefer that way of interacting with systems. Any others?
So how does this really differ from systemd nspawn?
I don't know. I haven't looked into systemd nspawn much at all yet. LXD is a wrapper around LXC, and LXC is something that has existed for years, old kernel stuff. LXD wraps it, abstracts some of the networking and other system aspects. Yeah. Any others?
So I'm curious about your workflow. So if you update one of your clients' websites, do you have a copy of that container locally and you just kind of throw it up on one of the servers? Or do you kind of like you demonstrated where you can copy a file into the container, and once you get the website updated, do you just copy it into the container, do the update?
For static websites, I just update that live. But when it's something like WordPress, yes, I'll have a container running locally, and I copy it to the remote system. Yeah.
And it looks like you're using Caddy. Do you usually do some type of proxy like that of sorts? And what does your disaster recovery look like?
Snapshots and good backups. I use TarSnap. Are you familiar with it?
Yes.
TarSnap is really fun. Oh, for those who are not familiar with TarSnap. Is this it?
Are you backing up the snapshot? Like you take the snapshot, then you have the TarSnap?
Yes.
Offload it? Okay.
I'm both backing up the snapshots I take of the containers, and I have TarSnap inside the container doing backups in there as well. Okay. So there's like 2 layers of backups.
All right. Thank you.
Okay, so it's been a few years since the last time I used LXC, and actually even Docker for that matter. What I remember as being the big difference was with Docker, you've got the Docker file, and essentially you're giving it instructions of how to build the image each time. Where with LXC, as I recall, you essentially have a persistent disk.
Yes.
And you can go in, just like you with a virtual machine, do everything you need in order to build that disk, and then it goes ahead and stays there
Yes.
for your next run, which I found to be extremely more convenient than having to get just the right formula into the Docker file.
That's what I prefer about system containers, yes. And then you can do things like turn, you can take a base image like the Debian images or the Ubuntu images or whatever, do whatever you like with them, make them, install Caddy, maybe by default. And you can turn, I don't remember the exact process, but you can turn that container into a reusable image on your own image server. So you can have private images that you can deploy at will that are already set up how you want them to be. Any others?
So you mentioned a lot of file systems there, but I noticed that ZFS was missing. Is that an option?
I don't remember. I don't think so, because it was not listed in that initialization process. But maybe it is. I think so. I think you can use it as a storage pool for your containers. I've never personally used it, but it looks like it is an option, just not one of the default ones. Any others? Sounds like that's all. Thank you. I did breeze through that much faster than I intended. But you've all got like 24 minutes or something to kill, so that's free time.